Hello everybody, this is Mr. Bear and I'm bringing to you Skill 20. This should say Skill 20, not 19, sorry. So last year we learned about the parent function y equals 1 over x, which is a rational function. Rational functions can have x's in the numerator and the denominator. So today we're going to look at the graphs of those types of rational functions. Sorry, having a hard time this morning. Anyway, so first thing we want to look at is the graph of the function y equals x plus 1 over x minus 2. So you can see that graph on the grid over here. It says what value of x makes the numerator equal to 0? Okay, so if I just take x plus 1 equals 0, we subtract 1 on both sides, and we get x equals negative 1. Okay. Mark this value on the graph. So x equals negative 1. Oh, there it is. Okay. So it turns out that is an x-intercept. Okay. Now I'm going to use red. It says what value of x makes the denominator equal to 0? Well, that would be x minus 2 equals 0. Solving that for x, we get x equals 2. At x equals 2, ooh, interesting. We have a vertical line, but no graph. So we're going to call this a vertical asymptote, which from this point on will be known as a VA. You're used to those. We've talked about those with exponential and logarithmic functions. All right, let's go ahead and look at the next part. It says the graph of the function y equals x plus 1 times x minus 3 over x minus 2, x plus 2 is shown to the right. All right, so I'm going to use green. What value of x makes the numerator equal to 0? Well, if we look here, we can see that we have x plus 1 equals 0, and we have x minus 3 equals 0. So we're going to have x equals negative 1. There's that. And I'm going to add 3 to both sides on this one to get x equals 3. So again, those are x-intercepts. Okay. Going to the next part, what value of x makes the denominator equal to 0? Well, it's going to be when x minus 2 equals 0 and when x plus 2 equals 0. So adding 2 to both sides on the first one, I get x equals 2. And when x equals 2, it looks like a VA. And then subtract 2 on both sides on the other equation, and we get x equals negative 2. So again, VAs. Okay. What does the numerator tell us about the graph of the function? Its zeros are the x-intercepts. And what does the denominator tell us about the graph of the function? Its zeros are vertical asymptotes. So far. And that can also be said about the x-intercepts. Okay, so now let's look at this function. Y equals x plus 5 times x minus 3 over x minus 3 times x minus 1. So it's going to ask you to identify any x-intercepts, identify any vertical asymptotes, and then graph the equation using Desmos. Are the x-intercepts and vertical asymptotes where you expected them? All right, so before we answer that, let me go ahead and pull up Desmos. Okay, so I'm going to pull this up. And I'm going to open in a new window, kind of set that to the side so I can see the function. And if we look at Desmos, and by the way, you could try this out with me. I'm going to put y equals, and then I'm going to make a fraction bar. I just hit the slash button on my keyboard. We have x plus 5, x minus 3, In the denominator, I have x minus 3 and x minus 1. Okay, so I've got the function in there, and according to our function, right now we're supposed to see that x-intercepts would be at -5 and +3. Okay, now let's see if that actually happened. So let's see, at x equals -5, let me zoom this out. Oh, I clearly see an x-intercept there. But at x equals -3, or sorry, not -3, +3. So 1, 2, 3. Oh, look at that. Look what happened there. See here where it says 3, undefined? I wonder why that happened. Okay. And then, of course, we know that x minus 1 at x equals 1, what happened on the graph? Let me zoom this out a little bit. You can see on both sides here, it looks like there's a vertical asymptote there. Let me draw that graph here. If we look at the graph here, x equals 1, you can see that both sides of this rational function are kind of merging towards that asymptote, but not going to actually touch it. Okay, so the x-intercept definitely happened at x equals -5, and the vertical asymptote happened at x equals 1. But let's see, we thought an x-intercept or VA would be at x equals 3, but instead there was a hole. And I'm going to go back to the graph one more time just to look at that. When x equaled 3, see how there's a hole in the graph there instead of it being a defined point? Like all of these are points. When I get there, it's a hole. So at 3, there's a hole in the graph, but not a vertical asymptote or an x-intercept. Okay, so what does this mean? It means that when we are looking at rational functions, okay, numerators not canceled out tell x-intercepts. You need to write these down. Denominators not canceled out tell VAs. Canceled factors from top and bottom give holes in the graph. Okay, so those are the key ideas. Those are the things you need to know. And so now what we're going to do is we are going to actually identify these things, okay? So we're looking for x-intercepts, holes, vertical asymptotes. Those are the things you need to know. All right, so before we can do anything, and I should make sure that you know this as well, factor first. Factor is a verb, okay? So make sure you factor everything first before you do any of those things. All right, so looking at the numerator here, I can see that I'm going to factor x squared minus 2x minus 3. What multiplies to -3 and adds to -2 is going to be -3 and +1. So x minus 3, x plus 1. In the denominator, I'm looking for two things that multiply to 8 and add to 6. So that's going to be 4 and 2. So x plus 4, x plus 2. And when we look here, let's start with x-intercepts. So x-intercepts are where numerators that are not canceled out have zeros. Okay, so looking here, x minus 3 does not cancel out, and neither does x plus 1. So your x-intercepts are, and you all probably could do this algebraically in your head, so the x-intercepts are at 3 and at negative 1. Okay. All right, let's do the vertical asymptotes. Vertical asymptotes happen whenever the denominator factors that don't cancel out are equal to 0. In this case, neither denominator factor was gone. So we're going to solve these out, and we get x equals negative 4. And we get x equals negative 2. So there's going to be two vertical asymptotes here. And now in red, holes. There are none. No factors canceled. Okay. All right, let's try the next one. Looks like I wrote over the problem there. Let's fix that real quick. Let me also circle the one I just erased. Oops. There we go. All right, looking at the next one, we can see, well, come on. Sorry. In the numerator, let's see, I'm going to write that as negative x squared plus 2x. What we're going to do now is factor. In the numerator, I'm going to factor out negative x, and that gives me x minus 2. And in the denominator, I'm looking for two numbers that multiply to a times c, so that's 40, and add to negative 14. So that's going to be negative 10, negative 4. Note that we have an a value of 5, so we're going to divide those by 5. And negative 10 divided by 5 is negative 2, so we'll have x minus 2. And then negative 4 fits, that 5 will go in front of the x, so 5x minus 4. Now looking here, I see that the x minus 2's cancel, which means we have a hole at x equals 2. VA's at x equals, well, let's solve that equation. So we have an uncanceled factor in the denominator of 5x minus 4. So I'm going to add 4 to both sides, and I get 5x equals 4. So divide by 5, and we get x equals 4/5 is where the VA is at. And using a different color, let's find the x-intercepts. X-intercept here, negative x equals 0, so we'll divide by negative 1, and we get x equals 0. Okay? Alright, last one here, I'm giving you a function that's graphed, and we are supposed to determine the x-intercepts, the holes, and the vertical asymptote so that we can write a possible equation. Okay, so x-intercept occurs, let's see, where do we have one? Oh, at x equals 3. Which implies then that the factor is x plus, not plus 3, sorry, x minus 3. Okay. Let's see, we have a hole at x equals 1, which means there is an x minus 1 top and bottom. I should have made note that the x minus 3 is on the top only. Now let's do the vertical asymptote. We can see that there's a vertical asymptote here at x equals negative 2, which implies the factor is x plus 2, and that is on the bottom only. Okay, so we must write a function now for this. So to write the function, we would write f of x equals, and so let's see, on the top only, I'm going to have x minus 3, and on the top and bottom, I need an x minus 1, and on the bottom only, I need an x plus 2. Okay, and we could multiply this out, get x squared minus 4x plus 3 over x squared plus x minus 2. There we go. That's it.